today's pattern will be fast and slow pointers. Okay, so yesterday we have covered 2 pointers and today we will be covering fast and slow pointers. Let's see what is fast and slow pointers. So basically this is also known as fluid cycle detection algorithm, or the tortoise and the hare technique, right? We will be having 2 pointers. One will be slow, means it will be moving slow, and other will be moving fast, right? It's a 2-pointer technique, right? And used to traverse data structures when elements are connected in a sequence, for example linked list, number transformation, and circular arrays, right? Mainly this will be applicable on linked list, we will see in the examples. And slow pointers, basically as I said, slow pointer will move slowly, it will move 1 step at a time, and fast will move 2 steps at a time, right? And these patterns can be useful in problems such as cycle detection in linked list or number sequences, finding the middle of the list, detecting palindromes in the linked list, right? And finding the starting point of the loop. We will see the questions and how to recognize when to apply fast and slow pointers. This is the main thing. Okay, basically in the question we will check if there are repetitions, like we need to find the repetitions. So like we are repeatedly transforming or traversing the values such as linked list traversals, or the square sum of digits. Let's say we are having one question, find the middle of the linked list. Okay, this is the linked list and we need to find the middle, right? So we will be having 2 pointers. One will move twice, like 2 steps at a time, and one will move 1 at a time, right? And when it will reach to the end, the fast pointer, we will get the slow pointer at the middle, right? So this is one of the use case. Cycle, possibility, the structure. Basically if there is some cycle, let's say in the linked list there is a cycle, right? After this again this node is coming, so this is a cycle, right? This is the cycle. So 2 pointers can be useful in this scenario, right? We will see in the example how to apply 2 pointers, not 2 pointers, slow and fast pointers, right? This is also basically a 2 pointers technique. We have mentioned like cycle in a linked list or number chain, and when we need to find the midpoint, right? I already mentioned this example, so same. And when we need O1 space complexity, like the constant space, in the question they have mentioned you need to use constant space. In that case we will be using this slow and fast pointers, because brute force can take n square time complexity, right, in some questions. So how to apply pattern? See, this is the technique, slow and fast pointer. By the name only we know that there will be 2 pointers, right? One is fast, one is slow. So first we initialize 2 pointers heading towards the to the head, right? They are initialized, right? After that what is the next step? We will traverse the structure, move slow by 1 step, and fast by 2 steps, right? And after that watch for a meeting point, right? In some question there will be a base case, right? What is the base case when we need to stop this traversal? So we need to watch for that. Most of the cases it will be when slow is equal to fast, we will stop, right? And we get to know that this is a cycle or this is the starting point, right? If fast hits null, no cycle. Let's say this was the case, right? In this cycle is there, let's say cycle is not there, and this last pointer is pointing to the null. Okay, in this case fast will point to the null, right? No, not the same node, we can say, right? So in this case cycle is not there. So this is also the case. We will check if fast equal to null, we can simply say cycle is not there, right? After that additional logic, we can apply the additional logic according to the question. We will, if you are looking for the cycle start, we will reset the slow pointer, and the we will check where fast and slow is meeting. Okay, I will explain this. At this point, this is the starting point of the cycle. I will show you how. Okay, if we are looking for the middle, return slow when fast hits the end. As I mentioned, when fast will hit the end point, our slow will be at the middle, right? Because fast will run 2 times and slow will run 1 time. Okay, so benefits, what are the benefits? It will take O n time complexity, right? No nested loop required. Instead of n square time complexity, we will be using O n time complexity, and constant space will be there. No modification, midpoint access, cycle detection. These are the use cases for the slow and the fast pointer. Okay, so now let's check the question. Detect cycle. Before this, let's understand this definition of the singly linked list. Okay, so basically we will be having one class, right? Okay, so class will be there, that is linked list, that is, this is one node. Okay, this is one node, and within this we will be having one value, right? One value will be there, let's say it has x value, right? And the address of the next node, right? The address will be the list node only, the type will be list node only, correct? So the singly linked list will have 2 parts, the value, its value, and the address of next node, right? Next node. So we will be having 2 parts. So we have the class, that is the list node, and within that we are having one value, its value, the address of the next node, that is of type list node only, and this is the address of next node. Okay, and when we are initializing this, we are passing the value, right? We are passing the value list node. Somewhere we are initializing this and we are passing the value like 10, right? Let's say new list node with the value 10. What it will do? It will create a list node with value 10, and the address of next will be null. Okay, we can further change it. Let's say its name is temp. Okay, we can change temp dot next. We are having, let's say, another list node, let's say temp1, and we can attach this with the temp, right? So now instead of null, it will be temp1, right? This is temp1, this is temp, right? So this is how we are attaching 2 list nodes, and this can also be having the value, let's say x value or something, right? So this is how we are initializing. This is the class of list node, we are having the value and the address of the next node. Okay, this is what list node, singly linked list. And if we are having doubly linked list, let's say it will be having one value and the address of the previous node, address of the next node, right? Now what is the additional part in this? It is having one list node variable here, right? Now we will be having one previous also, so list node previous, and it will be having the address of the previous node. This is what, this is doubly linked list, okay. So this is the basic definition of linked list. So let's check the question then. So given the head of the linked list, determine its if the linked list has a cycle in it or not. Okay, there is a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. Okay, so this is the image. Okay, so we are having the values, the linked list, this thing, right? We are having 3, we are having 2, we are having 0, we are having -4, right? And after -4 again 2 is coming, right? So cycle is there, correct? We need to find if cycle is there or not. How can we do this? We will use slow and fast pointer. How? Initially slow and fast pointer will be at head. This is the head. Okay, this is the head, right? So initially our pointers will be at head. Now slow will move with one step. Okay, slow equal to slow dot next. This is one step. And fast will move twice. Fast equal to fast dot next dot next. Correct? So this is one step. It's going one step ahead. It's going two step ahead, right? So in the first iteration, slow will come here and fast will come here, right? Correct? So slow will be at 2, fast will be at 0. In the next iteration, slow will come here and fast will come here, right? Fast will go 4 in the first step and 2 in the next step. So total 2 steps. So in the next, slow will come to 0 and fast will come to 2. In the next iteration, slow will come here at -4 and fast it will move twice. First this and second this point, right? Fast. So it will be at -4, both slow and fast. At any point, this if slow equal to fast, that means cycle is there. We can say cycle is there and we can return true, right? Correct? If at any point, let's say if after this 2 0 and -4, let's say nothing is there after this, right? It will be pointing to null. Correct? In the first iteration, initially slow and fast will be at our head. In the first iteration, slow will come here, fast will come here. In the next iteration, slow will come here and fast will come here, not here, null, right? It will move twice. Correct? At this point, if we get if fast equal to null, that means cycle is not there. We can say false. Okay, this is the simple logic, right? We just need to move the slow pointer by one step and fast pointer by 2 steps, and we need to check these conditions first. Is this one, if slow equal to fast, and this is the second condition, if slow equal to null, that means cycle is not possible, right? So let's write the code then. Okay, so first we will be having 2 pointers, that is list node, right? Node slow, it will be pointing to head, and fast pointing to head, right? After that we will be having one while loop. Now within while loop, what we need to check? We need to check if fast at any point if fast equal to null, or fast dot next equal to null. That means this is not the cycle, right? So within while loop we need to check the node condition, right? Now why we are checking this fast dot next? Because at any point, let's say this is the list, right? And after that null is there, so fast and slow. Okay, so in the first iteration, fast will come here, right? Now if we don't put this condition, fast dot next is not equal to null, then it will point to fast dot next, and we will get a error. It will say fast dot next does not exist, right? So how it will check the next for that part which is not there? So we are checking this condition, right? So while fast not equal to null and fast dot next not equal to null, right? At this point, what we are doing, we are moving the slow pointer by one step, dot next, and fast with 2 steps, fast dot next, right? So that's what we are doing. After that we have a condition, right? if at any point slow equal to fast, that means cycle is there, right? We will return true. And if it will come out of this while loop, right, that means either this or this condition is satisfied, that means cycle is not there, right? So fast is null, so we can return false, right? So that's it. Let's run this. Accepted, submit. So it's accepted. Okay, dry run. Okay, so see, initially our slow and fast pointer is at head, right? We have initialized this if slow equal to head and fast equal to head, right? So initially it will be there. After that we are running a while loop. Within while loop we are checking conditions if fast not equal to null and fast dot next not equal to null. Okay, I hope you got this condition why we are checking fast dot next, to avoid error, right? After that we are proceeding with slow and the fast pointer, right? Slow will move one step in the first iteration, slow will come here and fast will come here, right? It will move twice. Then it will check the condition fast equal to slow, it's not true, right? Then again we will enter the while loop. Again slow will move by one step, it will come here, and fast will move twice, it will move here, right? Again it will check condition is not satisfied, fast is not equal to null. Again it will go to the while loop. Again it will move slow by one step, fast with two step. Now it will check the condition, this one, it's satisfied, right? In this case it will return true. That's it. Otherwise if the cycle is not there, then it will point to null, and if fast will be equal to null, it will come out of the while loop and return false. That's it. Okay, adding one more node after 4. Okay, let's add it. Okay, so let's say cycle is not there, we are having one more node, let's say 5, and we are cycle from here, right? Now fast and slow will be at head. Now in the first iteration slow will move by one step, fast will move by twice. In the next slow will move by one step and fast will move twice, it will go to 5, right? In the next iteration slow will move by one step, let's say it will come here, and fast with 2 steps, it will go to 2, then 0, it will come here, right? In the next step slow will come here and fast will also come here, right? It will move twice. So we got the condition slow equal to fast, and it will return true, right? Okay, so see, if you want to know the starting point of the cycle, let's take this example. Okay, so what is the point where slow and fast pointer meet? Slow will come here in the first iteration, fast will come here, slow will come here, fast will come here, and slow will come here, and fast will come here, right? So this is the meeting point, right? This is the meeting point for fast and slow. Okay, let me write it like this: 3, 2, 0, then -4, then again 2, right? So this is the linked list, and fast and slow pointers are meeting at this point, right? This point. Now I am saying the distance from this node to the starting point of the cycle is x, right? And let's say the distance from the head and the starting point is p, let's say. Okay, and the total distance of the cycle, the total distance of the cycle is, let's say, c. Okay, let's say c. Now what is the distance of this part from the starting point to this meeting point? It's c minus x, correct? X is the distance from this meeting point to the starting point, so it will be c minus x, right? Now I'm saying, let's assume p is equal to x, let's assume this. We will prove this, but let's assume this. Okay, now we need to prove this. How can we prove? See, what is the distance of slow? It's from the head, it's p, right? P plus c minus x, right? C minus x is the distance from the starting point. This is the starting point and this is the meeting point. This is the head, right? So the distance from the head to the current slow pointer, it's this one, right? And what is the distance for fast pointer? It will be, see, what is the distance of the fast pointers? It cover the cycle one more time, right? As we see here, it covered the cycle again, then come to here, right? So we can say it's p plus c minus x plus c, where c is the total distance of the cycle, right? So this is clear. The distance of slow covered by slow and covered by the fast, this is the distance, right? It's clear. Okay, so let's code it. So this was the question. We are given the head and we need to return the node where the cycle begins. If no cycle is there, we will return null. Okay, so this is what I explained. So everything will be same, like we will be using the same code. Let's copy this. Additionally, we will be having some logic. Okay, so we are checking the fast and the slow pointers, right? At any point, if both are same, then we were returning the true. Now in this point, what we are doing additionally, we are initializing this slow pointer to the head, right? And this fast at the same position. Then we know the distance between this meeting point and the head and the starting point of the cycle and the head, and the starting point of the cycle to the meeting point is same, right? So first we are initializing the slow to the head, slow equal to head. Then we will be running a while loop. We know the distance is same till when? Till slow is not equal to fast. We will be running a while loop, and within this we will be moving slow by one step, slow dot next. Same with fast. Fast we will be moving by one step only, not twice, because we need to cover the distance, right? Both distance are same, we need to move by the same step. Okay, after that return what? Slow or fast, anything you can return. Here we can return null. Okay, let's run this. It's accepted. Submit this. Okay, it's accepted. You know, additionally what we are doing, we are initializing this slow to the head pointer. After that we know the distance between the starting point and the starting point of the cycle, and the meeting point and the starting point of the cycle is same. We have proved this, right? So we will cover the distance and with slow and the fast pointer, and at any point they are meeting, that will be the starting point of our cycle. Okay, so let's move to the next question. That is the middle of the linked list. Now we need to find the middle of the linked list. It's not like the array, right? It's the linked list. We don't know the size, right? So what we will do, we can't get the height of the linked list in array or array list. We have the method like length or size, but in linked list it's not there. So how can you find that? One way is first we can traverse the whole linked list. After that we will get the length and we can divide by 2 and again traverse the linked list by n by 2. Then we will get the middle element, right? It will take O n time complexity, right? Let's say this is the linked list. This is the linked list first, and we need to find the middle element, right? We don't know the size. Right? Initially in array or array list we have the methods like length or size, but in linked list it's not there. So for calculating the size, we can first traverse the whole linked list. We get the size, let's say n. After that we can traverse again till n by 2, and we will get the middle element, right? This is the one way. It will take O n time complexity, right? Can we optimize this? Yes, we can, using 2 pointers. How? Slow and head and fast will be pointing to the head initially, right? In all the cases, they will be pointing to the head initially, right? This will be our initial step. After that, we know slow will move by 1 step and fast will move by 2 step. Now, can you think how can we apply the slow and the fast pointer here? It's very easy. Same steps we are applying, right? So slow will be we will be moving by 1 step. Slow equal to slow dot next. You got the intuition. So fast equal to fast dot next, right? Till when? Till fast or fast dot next equal to null, right? Till when? Till then we will be running the loop. And see, in the first iteration, slow will come here, fast will come here. In the next, slow will come here, fast will come here. In the next iteration, slow will come here and fast will point to the null, right? So this is the middle element, the slow pointer, right? So let me code it. We will be having linked node is there. Slow, that will be equal to head initially, or let's fast will be equal to head only, right? After that we will be having one while loop. Till when? Till fast not equal to null, right? And within this we will be checking if fast dot next is equal to null, we will return the slow as the middle element, right? Return slow, because when fast will reach the end, slow will be at middle. Why? Because fast is running twice as slow, right? Fast is running twice. When slow will be here at the middle, right? Slow is at middle, fast will be at twice of middle, right? That is the end. So that's what we are checking here. If fast reach the end, that means slow is at middle. Otherwise, what we are doing, we are moving slow by 1 step, slow dot next, and fast by twice dot next, right? After that, return slow. Let's run this. Compilation error, head linked. It's not linked node, it list node. Accepted, submitted. So let's move to the next question. Happy numbers. Now here we will be applying fast and slow pointers on the numbers, not on the linked list. Okay, so this is important. So the question is happy. We need to find if number is happy or not. Okay. So a happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of square of its digits, right? Repeat the process until the number equal 1, and if it equal to 1, this is the happy number. Otherwise, like if it's a cycle, if it's loop endlessly in the cycle which does not include 1, that means this is not the happy number. Okay. So let's see the example. 19 we are given. What they are saying, we are having one number, let's say 19, and we need to basically find the square of the digits, that is 1 square plus 9 square. What is the answer? It will be 82, right? 82. Again the square, 8 square plus 2 square, it will be what? 64 plus 4, 68, right? Again 6 square plus 8 square, it will be what? 36 plus 64, right? Now it's equal to 100, right? Correct. After that 1 square plus 0 square plus 0, it will be 1 only, right? Again 1 1 1, right? 1. So we got 1. That means this is the happy number, right? So this is the logic we need to perform in the question. And let's say we are having one more example, that is 2, right? Now what is the square of 2? It's 4, right? Square of 4, it will be 16, right? For this it will be 1 square plus 6 square, that is equal to 37, right? After 37, what is the value? It will be 3 square plus 7 square. It will be 9 plus 40, right? 9 plus 49. What is the value of this? 58, right? 5 square plus 8 square, it will be 25 plus 84, that is equal to 9 to 10, correct? 9 and to 10, right? After this 109 we got. After this 1 square plus 9 square, it will be 81 plus 1, 82, 82, 8 square plus 2 square, it will be 64 plus 4, 67, 36 plus 49, and so on. Basically it will not end. Again we will get some digit which we covered here, right? So basically this is not the happy number, I mean to say, right? So how we will get to know? Either we will process each and every number and store it in some array list or something, and we will check if it's already present, then we can say this is not the happy number, right? If we got 1, then we can say this is the happy number, right? But this will take a huge time complexity, right? We are doing here, and this is not ending, right? Sorry. 68, after that 36 plus 64, it's a happy number then. Okay, it should not be happy number. I did some mistake or something. Let's calculate it again then. 2, let us do it again. 2 square is 4, right? 4 square is 16. 16, 1 square plus 6 square, that is 37, right? After that 3 square plus 7 square, that is 9 plus 49, right? What is the value? It will be 58, correct? After that 25 plus 64, it will be 989, right? After that 8 square plus 9 square, it will be 64 plus 81, right? Now what is the value? 5 and 14, right? Right. 8 plus 6 is 14. After that 1 square plus 4 square plus 5 square, it will be 1 plus 16 plus 25. What is the value? 6, 6, 12 and 42, right? 25 and 6, 12 and 42, right? After that 42, then 4 square plus 2 square, it's 16 plus 4, it's 20, right? Again we got 2, right? 2 square is 4. Again it repeated, right? It's repeating from here. Again we will get all these numbers. So it's not the happy number, right? What we can do, how to solve this? Either we can store each result in array list, right? We will be using extra space here, and the time complexity will also be increasing in this case. Or we can use the what? Slow and the fast pointer. How? This is the question now. Let me explain you. Okay, so we will be using slow and fast pointer, right? And slow will move by one step, that is we are doing 2 square, right? We are getting 4. Here we will be moving by twice. It will be 2 square and square of that, right? So here we will get 16. Using this step we will get this number, or not this. Initially also we will get the number, right? Basically like the linked list only, it will move, right? Like we are having this is the case in this case, right? We are having 2 and 4 and so on. Let's say x is there something, and again it is coming to 2, right? Using slow and fast pointer, how we can solve? Initially they both will be at 2, right? Now slow will move by one step, it will be here, fast will be here, right? In the next step, slow will be here and fast will be here, right? It's calculating the square of the square, right? Square of the square, fast pointer. After that, slow will come here, fast will come here, right? After that, slow will come here, fast will come here, and after that slow will come here and fast will come here, right? So this is the case. It's basically a meeting at the initial point only, but in some cases, let's say we are having the cycle from here, so it will be meeting at this point. So using slow and fast pointer, it will reduce the complexity, right? Let's explain this again. As we seen in the linked list, we are having some nodes, right? Let's say this is the case. We are starting with 2, then we are having some value 4, x, and so on. Something is here, right? Now we will be starting from slow and the fast pointer from here, right? After that, slow will go to here, right? Fast will go to here, slow will go to here, right? Not here, here. Fast will go to here. After that, slow will come to here, fast will come to here. After that, slow will come to here and fast will come to here. I'm doing it wrong, I think. There will be one meeting point before only, I guess. See, something is missing. 16, 37, 58, 89, 145, 42, 20. Okay, in this case it's 2 only, but in some cases it can be any number. Okay, let's solve this. We are having 2 pointers, slow and fast, okay, and we are having the number 2. Fast will move by one step, that is 2 square, and slow will move by one step, fast will move with 2 step, that is square of the square, right? So let's move slow and fast. Initially it will be 2 square, it will be 4, and it will be 2 square of square, it will be 16, right? This is the first step. After that, 4 square and 16 square ka square, right? It will be 16, and here it will be 1 square plus 16 ka square. What is the 16 square? 1 plus 36, it will be 37. Now 37 square is 9 plus, what is the value of this? 749, it will be 58, right? After that, the square of 16, it will be 37, and for this square of square, 25 plus 84, right? It will be 9, 64, it's there again, I'm doing the same mistake, 89, right? So we got now 89 square, 64 plus 81, it will be 45, right? We got it here also, 145, right? So 145, again the square of 37 is it's 58, right? 9 plus 49 will be 58. The square of this, it will be, square of this is 42, and again 42 square is 20, right? Again, next, what's next? it will be square of 58 25 plus what 64, 825 plus 64 89, and here it will be what again 4 not 4 16, right? Uh, 89 square is 64 plus 81 145. Here it will be the square of square. Plus 58 145 square is 42. Here it will be square of square 145. Okay, so in this case we are meeting at the initial point only, right? So we got this slow equal to this fast, right? But in some cases it will be at beginning point only, right? So this is the use case of slow and fast pointer, right? If we are doing like if we are storing the values in some array list or something, it will take extra space, right? Extra space will be there. Here we are saving our space, right? So that is the logic. So basically we can see it as a linked list only, right? Here what we are doing, we are having the slow and the fast pointer at the head, and we are moving slow with the one step and fast with the twice, right? And we are checking if they are meeting at any point, then we will say this is not the happy number, right? So that's it. Let's code it then. So we will be having 2 pointers and slow, and let's make a function that will calculate the square of the digits of the number, right? So int square int num. So for this we need to split the digits and calculate the square, right? So we will do what? While num is greater than 0, then what we are doing, we will get the last digit from it by what? With modulus, right? Modulus by 10. Then what? Then we will calculate the square and add it in our answer, right? X into x. After that we will divide the number by 10. I will explain this, and after that we can simply return ANS, answer, right? So what we are doing here, let's say we have the number 145, okay, 145. So first we will modulus this with 10. It will give the remainder, right? What modulus do? It will divide 145 divide by 10. It will go to 14, right? And it will give the remainder. So we will get 5, right? The last digit. We will calculate the square of this, that is 5 into 5 square, and add it in our answer. It's 25 now, and we will divide this 145 by 10. We will get 14. Again we will do the modulus. We are using the while loop, correct? We will get 4, the last digit. We will add 16. Again we will divide. We will get 1. We will do modulus. We will get 1 only, right? We will do 1. So we will get the sum and we will return this, right? So that's how we will get square of the digits of this number, right? So we will be passing n initially, and fast will be there. That will calculate the square of square. I'm doing it wrong. That's it. Okay, so we got 2 pointers, fast and slow. After that we will be running this loop till when? Till slow is not equal to fast, right? And slow we will be running by one step, that is slow is square of what? N, not n, the slow, right? And fast will be square of fast, right? We are moving the slow by one step and fast with twice, right? After that, in this we will check if slow is equal to 1, right? Or fast equal to 1, we can return true. Otherwise return false. Correct. Let's run this. Let's submit this. Wrong answer for 1. It's showing false. Square. Acha. Okay. We need to check here also if slow equal to 1. Let's submit this. Okay, it's accepted now. So basically what we are doing, we are moving the slow with the one step, that is the square of the number, and fast with the twice, right? Basically the main purpose of this, we are saving the space, right? And after that we are checking if slow is equal to 1 or fast is equal to 1 at any point, we can return true. That means this is the happy number, right? At the end we are checking if slow equal to 1, we will return true. Basically this is the condition, it will return true or false, whatever is there we will return that, right? It is not happy. In some cases the slow will be equal. Yes, in all cases they will be equal, either 1 or some other number. We will check at the end. Let's say in this case also we can remove this and run this. See, it's accepted. In all cases they will be equal. We need to check either it's 1 or something else. If it's 1, then we can say this is the happy number. If it's something else, let's say this we are checking this for 2, right? We are getting slow and fast equal to 2, right? 2 is their meeting point. So in this case this is not the happy number, right? So at the end we need to check if slow or fast is equal to 1, that means this is the happy number, right? On while condition. Okay, what we are doing in while condition, we are checking if we are running this while loop till slow is not equal to the fast, right? Why? Because we are running this slow with one step, that is the square, right? That is 2 square, right? Let's say, and fast with 2 steps, right? 2 square and then again square, right? So we are checking if they are equal at any point. Till then we will be running this while loop. After that we can stop, and at the end we can check if it's equal to 1, that means this is the happy number. Otherwise if it's something else, then it's not the happy number. Again, the questions you can try, these are the questions. You can also take the screenshot.